So we started the application of dipole moment, and the first application which we done is to find out the polarity of a molecule. Here we saw some diatomic molecules and find out their dipole moment, and what will be the result. If mu is equals to 0 for a diatomic molecule, then it is non-polar, and if it is not equal to 0, then this molecule is called as a polar molecule. Now we increases the number of atoms one by one, and next we see the polyatomic molecule having 3 atoms. Among 3, one is the central atom and other atoms are linked with it. So the result we discuss here, that if polyatomic molecule has symmetry, surrounded atoms are same around the central atom, and there is no lone pair of electron present on central atom. For these conditions, dipole moment of such type of polyatomic molecule is equals to 0. Hence, that molecule is non-polar molecule. But if our molecule is unsymmetrical, surrounded by different type of atoms, and having one or more lone pair on central atom, then for such type of molecule mu is not equal to 0. Hence it become polar. As we discussed about water, oxygen, as it having 2 lone pairs and 2 bond pair, the direction of these bonds, the dipole direction, is all the dipoles pointed out in upward direction. So resultant also in upward direction. Hence there is no cancellation of dipole moment in this case. Mu is not equal to 0. So molecule is a polar molecule, isn't it? Similarly, we discuss about ABF3. If central atom do not contain any lone pair surrounded by same type of atom, and the molecule is a symmetric, then its mu is equals to 0. Hence it is non-polar. So let us discuss some other examples to find out their polarity. Then some exceptions are also occur. First one is XeF4. Here if we discuss, then in this molecule 4 are the bond pairs. Total valence electron of xenon are 8. Then out of these valence electrons, 4 are used to form bond pair and 4 are used to form lone pair. So pair are 2. As we discussed, according to our rules, if molecule having a lone pair, then its mu is not equal to 0. But it is exception. First of all, draw its structure. Then with 6 having 2 lone pair, its structure is square planar with 2 lone pairs like this. Isn't it? So this one is the F. As we know, fluorine is more electronegative than xenon, then direction of dipole is from xenon to fluorine in all the cases. As the bonded atoms are same, hence the value of dipole moment of this bond is same in magnitude but with opposite sign to this dipole, hence both cancel each other. Similarly, with these two bonds, their dipole moment are opposite, hence they cancel out each other. And same with these lone pair, this is pointed in upward direction and this is pointed in downward direction. They cancel out. For this type of molecule, this molecule mu is equals to 0. Hence, this is a non-polar molecule, isn't it? Now next one, XeF2. Similarly, calculate number of bond pairs, total valence electrons 8. Among 6 there are 3 lone pairs of electrons. So the structure with 5. Symmetrical structure is trigonal bipyramidal, but due to the presence of lone pair, structure is not symmetrical. So this one is the central atom, 2 are the bond pair, and 3 lone pair are present, and so so this one is the structure of XeF2. Now if we see the direction of dipoles, then these both dipoles are opposite of each other, hence cancel out. And also with these lone pairs, the resultant of these two lone pair is in this direction, and if we calculate their resultant, then its value is same as of this. So every dipole moment cancel out with each other, so the net, it is called as net dipole moment of the molecule is 0. Hence molecule is a non-polar molecule. Okay, here very important question is asked in the exam, that among NH3 and NF3, which has high dipole moment. So first of all, to calculate the polarity, first to see in the molecule, either it is symmetrical, either it is surrounded by same type of atoms, or there is no lone pair, then clearly its mu, it is equals to 0. But if it is not so, then draw its structure. For example, in case of these molecules, firstly draw the structures of ammonia having one lone pair like this, and this one is the trifluoride with the same lone pair. This structure is called as a trigonal pyramidal structure, which is unsymmetric, and symmetric is called as a tetrahedral. So here the direction of the bond is from hydrogen to nitrogen, and of the lone pair is in the same direction. So for ammonia, overall dipole is in the upper direction. It means it has some value of magnetic moment, and for it, if we calculate, then it is 1.47 D. Now in case of NF3, here fluorine is more electronegative than nitrogen, then the dipole direction is this downward direction, and of this lone pair, it is upward direction. The resultant of these three bonds is also in the downward direction. Both these dipoles are in opposite direction with respect to each other. Hence, some dipole moment cancel out each other. And if we discuss about the net dipole moment of this molecule, then it is equals to 0.24 D. So according to this, NH3 has more dipole moment. It means it is more polar than NH3. Polarity, that is NH3 is more polar than NH3. So the next application is to determine symmetry of molecule. That also depend upon the value of dipole moment. That is, if dipole moment is equals to 0, then molecule is symmetric, isn't it, as we discussed above. Similarly, if it is not equal to 0, then molecule is unsymmetric. So the symmetry of the molecule is depend upon the value of dipole moment. Third application is to distinguish between ortho, meta and para isomers in aromatic compounds. First of all, what is this ortho, meta and para position? So, in the benzene ring, this is the benzene ring. If groups same or different, group, or we can say if group of atoms or atom linked at 1 and 2 position of benzene ring, then this 1-2 position is called as ortho. Suppose this one is 1, this is 2, 3, 4, 5 and 6. Similarly, if linkage is at 1-3 position, then it is called as meta. And if linkage is at 1-4 position, 1 and 4 position, then it is called as para. So, for example, we have 3 compounds in which 2 chlorine atoms are linked at benzene ring at 1-2 position, 1-3 position and 4 position. Then this position is ortho, this position is meta position, and this position is a para position. So among these three, if we form the dipoles, then it is from this one is carbon to chlorine, as chlorine is more electronegative. This one in this direction and in this direction. So if we see about the para position, if groups are attached at para position, then their dipoles are totally opposite, hence cancel out each other. So for mu it is equals to 0. Hence for para isomer, mu is equals to 0. So it is non-polar molecule. But in case of ortho and para, ortho and meta, greater the angle between two linked atoms, less is the dipole moment. So this is like, these dipoles are like this. This is the angle between these two bonds, and this one is like this. This is the angle between these two bonds. Hence dipole moment depend upon this angle. If angle is greater, its dipole moment is less. So according to this, ortho isomer has greater dipole moment than meta. Okay. Then order of dipole moment among these, order of mu become, this one is para, then meta, then chemistry. Last application used to calculate percentage ionic character in a molecule. So this percentage ionic character is equals to dipole moment which is observed divided by mu ionic, that is calculated. This value is calculated by us, multiply by 100. So to calculate the percentage ionic character, this is the actual dipole moment of the molecule which is given, and this one is the value calculated by us by given information. So for this, mu observed, it is given in the question, and mu ionic calculate by multiplying Q, that is charge, and D, that is intermediate distance. taken an example of this. So let us discuss it with the help of example. So question is calculate percentage ionic character of HCl given that observed dipole moment is 1.03 d and bond length is 1.275 angstrom. So for this mu observed is 1.03 d, mu ionic is Q multiplied by D. Q is the charge which is taken here as 1.4 into 10 raised to power minus 10. It is fixed. The separation of only one electron occur. Then multiply by distance. It is taken in centimeter. So first of all, convert this value, that is 1.275 angstrom, into centimeter. So it is equals to 1.275 into 10 raised to power minus 8 centimeter. So it is multiplied by 1.275 10 raised to power 8. So our mu ionic is it is equals to, again it is 4.8 into 10 raised to power minus 10 ESU multiplied by 1.275 into 10 raised to power minus 8 centimeter. While solving this, it becomes 6.12 into 10 raised to power minus 18 ESU centimeter. As we discussed, this value is D, hence 1 divided it is written as 6.12 D. So the percentage ionic character, by using the formula, it is mu observed, that is 1.03 divided by multiplied by 100. It becomes 16.83%. Okay. Next application is to distinguish between cis and trans isomers. These are in case of alkenes. So for example, we are taken here CH3, CH double bond CH, CH3. There are two possibilities to draw the structure of this molecule. One is like this and another one is like this. If we see clearly, then here to the double bonded carbon, hydrogen, both the hydrogen are present in one plane and methyl groups are present in one plane. These hydrogen are above the plane and in the same direction, and methyl groups are in the same direction. If same atoms or groups are present in same direction, then it is called as cis isomer. And if same group they are present opposite to each other to the double bonded carbon, then it is called as trans isomer. So if we calculate their dipole moment, then first of all form the dipoles. So double bonded carbon is more electronegative than single bonded carbon, hence the direction of dipole is upper direction. And for this is down. As the bonded atoms are not the same, their resultant in upper direction, their resultant in lower direction. But as the bonded atoms are not same, so some values cancel out, but net dipole moment is not equal to 0 due to the presence of different surrounded atoms or group. So for cis isomer mu of the molecule is not equal to 0. In this case, if we see, then dipole between the same bonded atom, they opposes each other. Hence this CH bond cancel out this CH, this one cancel out with this. So mu of this molecule, it is equals to 0. So if in an alkene mu comes out to be 0, then it describes its trans isomer, and if it is not equal to 0, then it is its cis isomer. Okay, so these are the application of dipole moment.